Example9.com.
Next question is also similar to the previous one, that is to prove that root 3 is an irrational number. Prove that root 3 is an irrational number. To prove root 3 is an irrational number. By explaining this proof, you will be very familiar with the proof. So, I shall explain the proof of root 3 is an irrational number also. First of all, we are assuming that if possible, let root 3 be a rational number. If possible, let root 3 be a rational number. If root 3 is a rational number, then root 3 can be expressed in the form P by Q or A by B. Therefore, root 3 can be expressed in the form P by Q, where P and Q are co-prime integers. Where P and Q are co-prime integers. That means P and Q are having only one as a common factor and there are no other common factors to P and Q. That is the meaning of P and Q are co-prime integers. Now cross multiplying, P is equal to root 3 into Q. P is equal to root 3 into Q. Now squaring both sides. Squaring both sides. We are getting P square is equal to root 3 into Q the whole square, which is equal to 3Q square. We are getting P square as 3Q square. That is, P square is equal to 3Q square implies P square is a multiple of 3. When Q square is multiplied by 3, 3Q square is a multiple of 3 and hence P square is a multiple of 3. That is, P square is a multiple of 3. Therefore, P is also a multiple of 3. Therefore, P is also a multiple of 3. P is also a multiple of 3. That means 3 is a factor of P. The converse statement is 3 is a factor of P. That is, 3 is a factor of P. We are noting this as statement number 1. Now we are taking P is a multiple of 3. Since P is a multiple of 3, since P is a multiple of 3, we can write P is equal to 3K. P can be written in the form 3K, where K is some integer. We are getting P is also a multiple of 3. We are writing this relation P is equal to 3K, where K is some integer. Now, P square is equal to, since P is equal to 3K, that is, P is equal to 3K. Therefore, P square is equal to 3K the whole square, which is equal to 9K square. But here we have the relation P square is equal to 3Q square. But P square is equal to 3Q square. Therefore, we can write 3Q square instead of P square. We can write 3Q square. That is, 3Q square is equal to 9K square. Therefore, Q square is equal to 9K square divided by 3, which is equal to 3K square. That is, we are getting Q square is equal to 3K square. Clearly, it's a multiple of 3, which is a multiple of 3, which is a multiple of 3. Since q square is a multiple of 3, q must also be a multiple of 3. Therefore, q is also a multiple of 3. Q is also a multiple of 3. That means 3 is a factor of q. 3 is a factor of q also. Here we are noting this as statement number 2. This is statement number 2. In the statement number 1, it is 3 is a factor of p, and in statement number 2, 3 is a factor of q. From 1 and q, from statements 1 and q, we are getting from statements 1 and 2, we are getting 3 is a common factor of p and q. From 1 and 2, we are getting 3 is a common factor of p and q, which is contrary to our assumption that p and q are co-prime integers. From 1 and 2, we are getting 3 is a common factor of p and q, which is contrary, means opposing, which is contrary to our assumption that p and q are co-prime integers. P and q are co-prime integers, that was our assumption, and here the statements are opposing the statement that 3 is a common factor of, from 1 and 2 we are getting 3 is a common factor of p and q. This statement is opposing, means contrary to our assumption that p and q are co-prime integers. That is, our assumption that p and q are co-prime is wrong. That means our assumption that root 3 is a rational number. Rational number is wrong. That means root 3 is an irrational number. That is, root 3 is an irrational number. Hence proved. So thoroughly well, study this proof also thoroughly well. Now you can try yourself that to prove root 5 is an irrational number. That is, the question is in your exercise, textbook exercise. So you can try the proof of, to prove root 5 is an irrational number. I am not going to explain root 5 is an irrational number. By studying the proof of root 2 and root 3, you can try yourself to prove root 5 is an irrational number. That question is in your textbook exercise. So try yourself to prove root 5 is an irrational number. Go through this proof. Instead of 3, you can write 5, and instead of multiple of 3, you will get multiple of 5. So you may try to prove root 5 is an irrational number. Okay.